Alright guys, what's up? Day 72, the 100 Days of LeetCode, problem number 112, path sum. So we're given the root of a binary tree and an integer target sum. We want to return true if the tree has a root to leaf path such that adding up all the values along the path equals target sum. And a leaf is a node with no children. Okay, so basically it's a binary tree. And we just want to see if the sum of one of these root to leaf paths, so for example, root to leaf, that's a root to leaf path. This is a root to leaf path, that's a root to leaf path, that's a root to leaf path. We want to sum up all the values in the nodes and see if we get our target value. For example, if our target sum is 22 in this particular tree, these four numbers, apparently according to LeetCode, sum up to 22. And we can check 2, 13, 17, 22, right? That's correct. Now here we have another one. We have 1, 2, 3. We have target sum of 5. There is no solution because there's no root to leaf path that sums to 5. First one, of course, sums to 3. Second one sums to 4. This one is false, and it's because the tree is empty. There are no root to leaf paths. Okay, so the first thing we're going to do in this solution is we're actually going to check for this example 3. We're just going to say if root equals null, we are going to return false, right? That makes sense. It's easy enough. If there's no tree, we're just going to return false. There's no root to leaf path, right? And it's the same as example 3. Now, this function is going to be a function that it's going to be a recursive function. So essentially, at the end of it, we're basically going to call it we're basically going to call it twice joined by an OR statement, and I'm going to write that out and then I'm going to explain it when we get to it. So we're going to return has path sum with root.left, and then we're going to do target sum minus root.val, or has path sum root.right, target sum minus root.val, right? Okay, so that's going to make sense in just a second. All right, so now, we've checked this. There is a root, so we're not returning false there. What do we do next? Okay, so first thing we do is we check, or not the first thing we do, the only thing we really do is we check whether or not it's a leaf. And the way we do that is we say if root.left equals null and root.right equals null, right? If both of the if its left and right pointer are both equal to null, that means it's a leaf because it's got no children, right? It's pretty simple. Okay, so now we know that we're at a leaf node. So what we need to check is we need to check if target sum minus root.val equals 0, we are going to return true. And then if not, we're going to return false. Okay, so how does this work recursively? All right, so the first time that this function gets called, we get our target sum passed into it. Okay, so let's say our target sum is 5. All right, it passes this, of course, because our root isn't null. Now, in here, we're going to find that the root of this particular, let's say example 2, is not a leaf node, so this doesn't even happen, right? We just skip through this if statement, and we go right to the return of the first recursive call to the function. So now what we're going to do is we're going to return basically the OR of these two statements. So now let's try this one out. We're going to take the target sum that was passed in initially, which was 5, minus the root.val, which here is 1, and pass it in as the target sum of the next call over here. Okay, so now we're going to pass in 4, right? And then it's going to be root.left as the root. And then when we enter that call, and we basically go through it on that particular part of the stack, we're going to find that it is a leaf node, and then we're going to do this check, and we're going to have if 4 minus 2 equals 0, which of course is false, we're going to return false, right? And I guess a cleaner way to do it, you could just do return target sum minus root dot val equals 0. I guess that's cleaner. Okay, so we'll do that. So we're going to find out that this is actually false. So we're going to return false from this side. All right, now we go back up the stack and we do this call, right? And now it's the same thing. We're going to pass the initial target sum, which is 5 minus 1. All right, we're going to pass 4 in. And root.right is now this node, okay? And then we're going to enter this. Of course, the root isn't null, but it is a leaf, so we enter this. And then we're going to return 4 minus 3 equals 0, which is, of course, false. And we're going to return false. Now, back to the first call of the function, we're going to essentially have return false or false, which, of course, is going to be false. All right, and that's how basically the recursion is working for this problem. So let's submit it, make sure I didn't mess anything up. There you go. So that's how you solve that one. That was day 72. We'll be back Monday with day 73. So please like, subscribe if you enjoyed that video. Take care.